Hello, everybody. Welcome to another video. Let's try keep this one short today. Why don't ducks ever have spare change? They only carry bills. Quack, quack. Okay. Oh, man. These are getting worse and worse. All right. So today we're using counting techniques and probability. So very, very quickly, don't forget what probability is all the way from basically, year 2, year 3, up until year 12. Probability is always the same thing. It's the number of favorable outcomes over the number of total outcomes. Okay. So with that in mind, now 4 cards are dealt from a pack of 52 cards. Hopefully you guys know how to use cards, how to play with cards. Find the probability that you get 1 club and 3 hearts in any order. Okay. So in this here, if it's in any order, that means I'm not really counting all the different orders. So that means, in a sense, I'm going to have, if it's 1 club, there's 13 clubs and I'm choosing 1. If I'm talking about 3 hearts, there's 13 hearts, but I'm choosing 3. And that's going to be all over. Well, I've got kind of 4 cards here that I'm trying to pick. So, and because the order doesn't matter, it's actually going to be 52 choose 4, because that's how many total I could have without any restriction. So maybe, you know what, I'll get my calculator out for this. So this would be 13C1 times 13C3 all over 52C4. This one will be, that'll be the probability, 286 times out of 20,825. Right, so not very likely, about maybe 1 in a, is it 1 in 100 chance? Yeah, 1 in 100 chance roughly. Okay, now what if I wanted to find the probability of 1 club and 3 hearts in that order? Okay, so in other words, I want you to think this way. It's kind of, we can think of it in 2 different ways. Let me think of it in a logical way first. The first one would be, if I want the first one to be a club, it's going to be 13. 3 hearts is 13 times 12 times 11. That's the hearts, because there's 13 hearts at first. And then once I pick the first heart, there's 12 ones left. Then there's 11 ones left after. That's the amount of ways I can get it done. But it has to be in a certain order. So in other words, it'll be 52. I have 52 choices for the first, 51 choices for the next, 50 choices for the next one after that, and then 49 for the one after that. So in other words, it's going to be, it's kind of like 13P1, because it doesn't really matter if it's just P1. But I'm going to multiply it by 13P3, because order now matters. So, and then at the bottom, this is just going to be 52P4. All right, so there's 2 different ways you can think about it. And then if I just write this down, let's see if I can just quickly change all of these to P's, so I can give you a nice number answer here. Okay. By the way, I'm sorry if I sound dead in these videos, because right now it is like 5 a.m. or 4:30. I know it says 9:41 a.m. on my iPad, but it's really 5:30. Okay. And this one here is, there's 143 out of 41650. And that sounds about right. It's a bit more rare than the one above because the order now matters. Okay, that's that one. Now, let's do this question here. It's a bit of a stacked question. Let's find I think this is the last one. Okay. This one here, you're going to have to think. There's no other way to put it, but you're going to have to think. Now, it says a 5-digit number is chosen at random. Find the probability it is at least 60,000. So first things first, if I'm picking 5 numbers here, 1, 2, 3, 4, 5. So if it's at least 60,000, that means the numbers I can choose are 6, 7, 8, 9. And those are the first choices I have for the first one. So I'm going to have 4. And then the next numbers don't really matter as much because I can repeat. So that would be it. Now the total, how many can I choose from the total? Well, the total, my number can't start with 0. So it's kind of going to be 9. And then I can have zeros afterwards. So it's going to be times 10, times 10, times 10, times 10. That's 5. All right. So in other words, here the probability will be, I'm pretty sure if you cancel everything out, it'll be 4 or 9. Right. So probability of number being greater than or equal to 6,000 is going to equal 4 or 9. There we go. We got there. Okay. So it's just going to be this one because it's the number of favorable. That's how many were favorable. That's the number that were total. Yep. Hopefully it makes sense why we chose that 9, because that 9 there, this guy here, is because we can't start with a 0. So that means we only have 9 options for the first number. But anything after that, I can have a 0, I can have a 1, 2, 3, 4, 5, 6, 7, 8, 9. That's fine. I just can't start a number with 0. So that's why there's 9 and then 10 choices for the rest. Hopefully that makes sense. Now, what if I want to find a 5-digit number that consists only of even numbers? So again, we know that the total is going to be 1, 2, 3, 4. It's going to be 1, 2, 3, 4. There's 90,000 total unrestricted ways that we can choose. And then if I want to consist of only even numbers, if it consists of only even numbers, now what happens here is, sorry, it's so early in the morning. It consists of only even numbers. What are your even numbers? You got 2, you got 4, you got 6, you got 8, and you got 0. Now, can you start with 0? Can't start with 0. So in other words, you're going to have 4 choices for the first number and then 5 choices for the rest. So whatever that is, what's 4 times 5 to the 4? 4 times 5 times 5 times 5 times 5. It's going to be 2,500. And then putting that over 90,000 is going to give you 1 on 36. So that's the probability that it will consist of only even numbers. There you go. Now, let's see how many ways we can find where it is made up of distinct numbers. That means we can't use the same numbers twice. So again, this means we can't use the same number twice. So it's going to be, if I'm doing a 5-digit number, 2, 3, 4, 5. For the first number, I can have 9 options. Okay, because I can't use 0. All right, but then after that, I'm going to have 9 times 8 times 7 times 6, because once I use a number, I can't reuse it. So, and that's going to, so the total, or the probability, sorry, I should say, probability of my event is going to be, what is 9 times 9? 9 times 9 times 8 times 7 times 6. This equals to 27216 all over my total, which again was 90,000. So again, that would give us 189 over 625. All right, last one. Okay, now this one here is a little bit tougher. Now, distinct digits and in increasing order. Now, this one here is kind of a bit of a weird one. So distinct digits and in increasing order. Okay, so for this one here, you're actually going to have to use a combination. Now, let me explain. So it's kind of going to be, well, we've kind of got 9 choose 5. Right. So if we go 9 choose 5, that means that we're picking 5 numbers. Right. Now notice I'm not saying 10 choose 5. It won't be 10 choose 5 because again, I can't really pick 0 because if 0 is in the equation, you can't have 0, 3, 4, 5, 6. Like that's not a number. Can't start a number with 0. Okay, if it was a pin, sure, but if it's a number, no. So that means we've got 9 options and we're choosing 5. And the only reason that we're choosing 5 here is because out of this group, there's only really one way we can order it. So it would be 9 choose 5 over a total of 90,000 because there's still that many total. And so calculating that, 9 choose 5, 9 choose 5 ends up becoming 126 over 90,000. And then simplifying that, that becomes 189 over 625. I think. Let me double check. I don't want to get this wrong. 9 choose 5 over 90,000. Oh. That is not correct. It should be 7 on 5,000. Let me just double check here. Okay, I wrote the wrong thing. So 126 on 90,000. Yeah, is 7 on 5,000. Okay, and there you go. That's it. That'll be it. Hope you enjoy. Hope it makes sense, and I'll catch you later. Bye-bye.